It's the largest rocket ever built, taller than the Statue of Liberty, more powerful than Saturn V, and fully reusable like an airplane. Wrapped in stainless steel and powered by the most advanced rocket engines ever built. But this isn't just a rocket. This is SpaceX's Starship, a machine designed to do what no spacecraft has ever done before: carry humans beyond the moon, and all the way to Mars. But here's the question: can SpaceX's Starship really take humans to Mars? Or will it collapse under its own engineering ambition? Because if Starship works, it will change everything. Space travel, colonization, even life beyond Earth. But if it fails, it could end Elon Musk's dream forever. Today we're going to uncover the genius engineering behind Starship. Its design, its engines, its fuel, and its audacious mission to make life multiplanetary. This is not science fiction. This is happening right now. Why Mars? Because it's the closest planet where humans could survive, with water ice, a carbon dioxide atmosphere for fuel, and days almost as long as Earth's. But it's also 140 million miles away. Reaching it with today's rockets is like trying to cross the ocean in a fishing boat. NASA's Apollo rockets reached the moon, but Mars demands something bigger, reusable, and far cheaper. So how do you build a spacecraft that gets us there, lands safely, supports life, and comes back? The answer is Starship. SpaceX was founded in 2002 with one clear goal: to reduce the cost of space travel and make human life multiplanetary. Unlike any rocket before it, Starship is designed to be fully reusable, capable of carrying 100 to 150 metric tons of cargo, powered entirely by next-generation methane engines, scalable enough to make regular interplanetary flights. Starship isn't just about exploration. It's about rewriting the economics of space travel, bringing costs down from hundreds of millions per launch to just a few million. But to achieve this bold vision, Starship's design had to break almost every rule of rocket building, starting with its unusual choice of material. It's a two-stage system built entirely to be fully reusable. Height: 120 meters stacked, booster and ship. Diameter: 9 meters. Its exterior is made of stainless steel, specifically 301-304L cryogenic stainless steel, not carbon composites or aluminum like most rockets. Why? Because stainless steel offers three key advantages. 1. It withstands extreme heat, crucial for re-entry. 2. It's cheap compared to exotic materials. 3. It reflects sunlight, helping with thermal control. Super Heavy Booster, the first stage, powered by 33 Raptor engines, designed to lift Starship into orbit. Starship Upper Stage, the spacecraft itself, with 6 Raptor engines, living quarters, cargo bays, and heat shields for re-entry. Together, they form a two-stage rocket system unlike anything in history. But even this towering design is meaningless without what lies at its heart: an engine unlike anything humanity has ever built before. At the core of Starship is its engine, the Raptor. This isn't just an upgrade of old technology. It's an entirely new approach. Most rockets use either kerosene, like Falcon 9, or hydrogen, like NASA's Space Launch System. Starship uses liquid methane and liquid oxygen. Why methane? It delivers high efficiency. It burns cleanly, reducing carbon buildup inside the engines. Most importantly, it can be made on Mars. Raptors use a full-flow staged combustion cycle, meaning both the fuel and oxidizer are fully pre-burned before entering the combustion chamber. This makes Raptor one of the most efficient and powerful engines ever created, producing over 230 tons of thrust per engine. With 39 Raptors in total, Starship generates more liftoff thrust than Saturn V, the rocket that took humans to the moon. But here's the catch. Even with all this power, Starship cannot carry enough fuel to return from Mars. The solution? Turning the red planet itself into a refueling station. Carrying enough fuel for a round trip to Mars is impossible. That's why Starship relies on one of the most daring ideas in space travel: ISRU, in situ resource utilization. On Mars, the thin atmosphere is 95% carbon dioxide. Combine that with hydrogen from Martian water ice, and you can create methane and oxygen fuel using the Sabatier reaction. The formula is simple chemistry: CO2 plus 4H2CH4 plus 2H2O. In plain terms, carbon dioxide plus hydrogen produces methane and water. This allows Starship to refuel on Mars itself, making return journeys possible without hauling massive amounts of propellant from Earth. This is the single biggest engineering breakthrough enabling human colonization of Mars. But if making fuel is possible, landing safely to use it is another story. And Starship's landing system may be its riskiest gamble yet. Traditional rockets are single-use. Imagine if airplanes were thrown away after one flight. Air travel would be impossible. SpaceX solved this with Falcon 9 reusability. But Starship takes it even further. Both the Super Heavy booster and the Starship spacecraft are fully reusable. Instead of parachutes, they rely on controlled landings, guided by engines and fins. Unlike most rockets moved horizontally before launch, Starship is too big, so SpaceX built a 480-foot launch tower with giant steel arms, nicknamed Mechazilla, to stack, refuel, and even catch the rocket mid-air. It's not just a pad, it's an entire robotic system. Steel arms lift Starship onto the booster. Fueling systems pump in methane and oxygen cooled to cryogenic temperatures. Giant water deluge systems blast the pad during liftoff to protect it from 16 million pounds of thrust. This is the first time in history a launch tower is not just infrastructure, it's part of the rocket system itself. But all of this engineering complexity comes at a cost. One mistake could set back the program by years. The goal is to reduce refurbishment time, making spaceflight as routine as air travel. The ultimate target, $10 million per launch, a tiny fraction of today's costs. But with reusability comes new dangers, from heat shield failures to orbital refueling challenges. And if even one of these systems fails, Starship's dream of Mars could collapse overnight. We've already seen Starship prototypes end in fireballs because of engine failures. Can Starship survive the heat of re-entry? Leaving Earth is hard, but coming back is harder. When Starship re-enters, it slams into the atmosphere at 25,000 kilometers per hour, creating plasma hotter than the surface of the sun. Starship carries thousands of black hexagonal heat shield tiles, flexible, shock-absorbing, and replaceable like Lego. But if even one fails, the rocket could disintegrate. That's why every Starship test flight is also a test of this heat armor. And heat is just the beginning. Starship faces enormous challenges that engineers are still solving today. Structural stress from unprecedented aerodynamic forces. Fueling logistics requiring multiple Starship tankers performing precise docking maneuvers. Human survival, from radiation shielding to life support to artificial gravity. Each problem is a frontier of science and engineering, and every test flight brings new lessons. But even if SpaceX overcomes these challenges, one question remains. What will Starship actually do once it proves itself in space? Starship's mission isn't limited to Mars. Its design unlocks possibilities across the solar system. Imagine high-speed point-to-point travel on Earth, turning global trips into less than an hour, or giant cargo delivery and lunar landers for NASA's Artemis program. Even space telescopes bigger than anything we've ever launched, but the crown jewel remains Mars. A fleet of Starships, refueling in orbit, could ferry the first settlers, equipment, and habitats to the red planet within our lifetime. But this leads to the ultimate question, not whether Starship can get us to Mars, but whether humanity is truly ready to take the leap. When Neil Armstrong set foot on the moon in 1969, it was humanity's greatest achievement. Today, SpaceX's Starship promises to take the next step, turning us into a multiplanetary species. It's a machine that is as much about human survival as it is about exploration. Because one day, Earth may not be enough. And when that day comes, the engineering of Starship will be the bridge that carries us to a new world. Thanks for watching this episode on SpaceX's Starship, here on Corecraft Engineering. If you enjoyed it, don't forget to like, subscribe, and turn on notifications, so you won't miss our next deep dive into the inventions shaping the future. Until next time, keep looking up.